guys, welcome back to my channel. In today's lesson I'll be teaching you a very important aspect of physics, which is measurement. Did you know no fact in science is accepted or established unless it's exactly measured and quantified? Well, most people didn't know that. So today I'll be teaching you the fundamental and the derived units under measurement. Length, mass, and time are the most important basic quantities in physics. Just like the way I've written it on the screen, they are known as fundamental quantities. You might be asking, what are fundamental quantities? Well, fundamental quantities are basic quantities that are independent of other quantities. That means they cannot be defined in terms of other quantities or derived from other quantities. We know our length, time, and mass are the three most important basic quantities in physics. Then I listed some others that are also fundamental quantities. That is the electric current. We know the unit is ampere and the abbreviation is A. For temperature, Kelvin, and the unit abbreviation is K. For an amount, the amount of substance is mole, and the abbreviation is just mole. It's full stop. And then I'll be teaching the opposite of fundamental quantities, which is derived quantities. Let me just write that: derived quantities and units. The derived quantities are dependent on fundamental quantities, so it's just the opposite of fundamental quantities. I'll give you an example. I have force. We can get force from mass times acceleration. The derived unit will be Newton. And energy or work and the derivation is force times distance. That is joule. Joule is the derived unit. We know the derived unit for force is Newton. That is mass times acceleration is Newton. So wait, let me just clean that. So since Newton is for force and energy is force times distance, since energy is force times distance, the force there represents Newton and distance is m. So that's how we get our Newton meters for energy. Likewise, you can use it for the rest of the derived units. Let's look at another one, like power, for instance. Power is work over time. We know that work is measured in joules. Yes, measured in joules. Then over time is measured in seconds. That is J over S or JS minus 1. That's how it's written. So momentum is mass times velocity. Our mass there, let's see if we can do this. Our mass is in kg. Our mass is kg. As for the mass, then velocity is meters per second. Just to make it clear, there's a difference between velocity and acceleration. Acceleration is meters per second squared. For velocity is meters per second. Then for pressure, it's force over area. I've already explained how you get them. We know area equals length times breadth. We know volume. Then for density, we know our density is can be drawn as this, and we'll have our kg over meters cube. So when you bring it up, it will be meters minus 3, m to the power of minus 3. So here they showed the difference between velocity and acceleration, like I said in the other time. Here we see velocity is displacement over time, and acceleration is change velocity over time. The derived unit for velocity will be ms power of minus 1, and for acceleration it's meters per second squared. For velocity it's just meter per second. So that's why I like this topic. It's a very clear and understandable topic for children, for everyone, not just kids.